In this presentation, I'm going to talk about data classification, and I'll be showing the content of my presentation based on the data that I'm using, the stellar data that I pulled from this website, Kaggle website, and then I'm using a portion of that data to work on. So in this, I have a few column, and I have a few column, but I'm going to base only on the three main column that I put in my assignment here, as I'm going to show it. That's where I'm going to um, put my effort to, and those columns are going to be Galaxy, Star, and QSO. What is that? I'll be coming to that very soon. Let me start from the code side, explaining what I've done so far from the code side, and then I'll be coming to that. So when I upload this data, this is the data, the source of it, and then I've defined the redshift, the lot of columns here, and as we can see, as I'm going to the right side, I'm seeing the data class. The data class, that's where I'm going to focus on the Galaxy, the stars, and QSO. So coming to the code, as always, I pull the necessary libraries and the binaries, and and packages to be able to execute my code. So I have a classification report and a confusion matrix, and confusion matrix display accuracy score and precision score, recall score, and F1 uh, score, which is a future one score, to show, and all these are I have them elaborated here. As you can see, that's a class distribution of the data set, and this is another diagram of the color, that where we can see the Galaxy, QSO, and the star. That those are the three main columns that I'm using in this particular data classification and the data improvement. So, and then I will be showing data confusion matrix decision, and most of the things are my main focus was I use logistic regression and decision tree most of the time to perform the data classification and data improvements, as you can see. So coming to the code, so as I pull all the library, now I have to define the function. I load the data set here, and this data set contain the entire data. I carry to 200, even though it's saying here 1,000, 100,000. So this is where I focus: Galaxy, Star, and the QSO. Those are the three columns that I'm focusing on. So after I loaded the data sets, so I have to now focus on the columns, and these columns are where I talk about the redshift, where I'm going to present the reports at each data class. And after that, I define also if we want the data to be in the P in the data. If we This is just a function to inject the missing value. So now I come down to pre-process the data. So pre-process the data is the missing data techniques that I use here to maintain my strategy to be able uh, 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 to classify. And as you can see from, I'm going to show put all this code in my technical reports. The code is going to be in my technical report. I will be showing B here, future engineering, which is the future F1 FE1, which is going to be future engineering. This code I'm going to put it there, and that future engineering is going to be printing the content of all these colon U, G, GR, and so on. And then I'll be showing the FE2, which is the future engineering 2. So apart from that, I will come in to show the content, the result of future selection, and after that, and then I'll be talking about subnets, and this is where I define the function to split the data split. So I just took like no, after this, so then I will build and run the models. The models, this is where, when building the model, this is where I'm going to use logistic regression and decision tree for my data classification. So to predict any result or any data output. So this is where I'm using the logistic regression and decision tree to return the output. Then after that, I define to display all the outputs for me, focusing on accuracy, precision, and recall, and the classification report. So yeah, and then you will see the diagram as I show here, and I define them all in the code. All these are in the code, as you can see. Distribution, the class distribution is right here, as I show. If we come down to the color diagram, the color diagram also is in the the code right here, and it's in the codes. I think it's down, and the confusion matrix decision is right here, as you can see, and the confusion matrix logistic is also right here, as we can see from the code side. This is the comparison, and as the color side, the color size, as you can see from my code, I define all the color that I use to color the diagram. And now I have to define the main function. The main function, that's where I process all the data to get the outputs for the final results. So from there, I have put the report together. But before going to the report, I would already execute my code. But I'm going to execute it one more time again. As I execute the code, Python 3, the file. So this is the dataset. This dataset, I'm going to add it to. So as a result of execution, I have the data class here where I have my galaxy, like I said at the beginning. I have a 39 as a 139, sorry. And then I have a QSO, which is a 31, and then I have the star, which is this, and the data and the class distribution plot saved output as I show it earlier. So that diagram is in here, as you can see. We can see this galaxy color, which is a 139, and QSO, which is 31. You can see, and 29 for star. They are almost at the same level, and the huge value here is the positive value, and the big value is the galaxy, as you can see. So let's go back to the output and the reprocessing. So we have a missing value in the photometrics, which start from the bound is like a 0 to 0 median. And the future engineering color, as I mentioned in the code, these columns are just added, but the result is not that something that I'm expecting. to get. But the main report I'm expecting to get is the logistic regression report, where I have accuracy, precision, recall, and futuring. And also I have a classification report. And after that, I have a decision tree. Yeah, decision tree result here. So I will be adding all these to my technical report and submit. So coming to the technical report, as I already explained, the data I'm using is from a survey. It's from a Sloan digital survey measure for this same data I'm using. So that data I show it earlier, but I can still show it here in uh, in in these data sheets. As I show it here, you can see I'm just using I cannot use the whole lot of it I just cut it off, and I'm using I think 200 of it only. And this is where I'm focusing on the galaxy, QSO, and the star. These are the data classification I'm using from it, combining all these to get the outputs. So yeah, based on that, so as in my reports I mentioned that as we can see, the galaxies is the dataset typically have a we know we have a positive redshift value, and that redshift value I define in my code as I mentioned it earlier. I define that positive value in my code, redshift. That redshift, I think we have it at some point here. Uh, yeah, as you can see, I define it, the redshift here at some point, and it's being defined also uh, at the beginning of my data. After I process the data, yeah, it's being defined somewhere also. So let me go back to the report. So yeah, and as we galaxy has a positive value, we can see that the star also has a value close to zero. And QSO has a very large value, and this QSO is uh, uh, we can say that typically have a extremely large redshift value that are incredible far away. So, well, I'm talking about the galaxy. It's like our solar system where we have the stars, all the objects that is around us. The data is talking about. The survey data is talking about that, and for the algorithm of the solution, this is the implementation part of the code that is a part of it to show the logistic regression and the decision tree classification, as I mentioned in the code, as you can see. So coming down, I talk about the future engineering, which is one, and then I have another one which is two here. So, and I give a little presentation or a little bit of the codes that illustrates these data performance or data classification. Going down to each level, you can see logistic regression. That's my main focus. Uh, and decision tree, and the reports are here. I put the report in this table, and we have accuracy, precision, recall, and futuring score. And as you can see from also here, I put that record here, but I'm going to add the execution screenshot that I have from as an output from my execution here from the code to the report sheet before submitting. So this is it. I've shown all this in my presentation already. So yeah, thank you for watching, and this is the end of it. Yeah, sorry. For the any analysis of finding, I discovered that once I perform all this and then I read about so many things, I discovered that the decision tree and the logistic regression perform almost the similarity of we use them to as an end result to get the same output. That's where the similarity is between decision tree and the logistic regression. So there's a similarity to get the same. If you are either we use a decision tree or we use regression, logistic regression, we are about to get almost the same result. So this is my presentation, and then I gave a few example of a logistic regression that show uh, compared to decision tree also. So thank you for watching, and yeah, thank you. And then I'm open to any feedback.